Welcome back, everyone. So today we're going to begin our module on polynomials. Okay, and before we get started on polynomials, we're just going to go over some basic definitions that you need to know in order to deal with these polynomials. The first definition that I want to go over is a monomial. And a monomial is a polynomial that has one term. And to go even deeper, a monomial consists of a number, a variable, or it's a product of a number and a variable with exponents that are whole numbers. So for example, the monomial that's listed here, 3w squared over 5. It consists of a number, in this case a fraction, which is 3 over 5, a variable, and a whole number exponent. Okay, the next term I want to go over is a binomial. And a binomial is just like the prefix bi. Bi means two. So think of a bicycle. A polynomial with two terms is called a binomial. And so a binomial, what I want to point out, is made up of two monomials, right? This is a monomial and this is a monomial. The last thing that I want to go over is a trinomial. And prefix tri means three. Think of a tricycle, so it's a bike with 3 wheels. It's a polynomial that has 3 terms, or made up of 3 monomials. Okay. Now, when we there's a way that we classify polynomials, and we classify polynomials by the degree of the polynomial. And what the degree is the greatest sum of the exponents of each term. Okay, so in this first example, we have a binomial because we have 2 terms here. We have the first term is 6x cubed, and the second term is negative 5x squared y squared. Okay, and so if we wanted to find the degree of this polynomial, well, for the first term, which is 6x cubed, we look at the exponent. The degree of this term is 3. For the second term, which is 5x squared y squared, the degree of this term is going to be the sum of the exponents, which is going to be 2 plus 2, which is 4. Okay, so the degree of the first is 3, and the degree of the second term is 4. So we choose the highest degree, which is going to be 4. So this first example is going to be a polynomial of degree 4. Okay, for the third, for this next example, we look at the exponents. So in the first one, this is just, remember, 3 to the 5th power is just a number. So this is going to have a degree of 0. For the second term, it's a degree of 2. And for the third term, remember, anything, this the exponent on the end is 1, so this is a degree of 1. So this example is going to have a degree of 2. Okay, so let me just erase this right here. Okay, so this is going to have a degree of 2. So this is a second degree polynomial. Okay. So, and next, what we can do with polynomials is we can evaluate, just like we evaluate linear functions where we're given a value and we plug it or substitute that value in for the variable. We can do the same thing for polynomials. So for example, if we had a skyrocket is launched from a 6-foot high platform with initial speed 200 feet per second, the polynomial negative 16t squared plus 200t plus 6 gives the height in feet that the skyrocket will rise in t seconds. So this polynomial that we're given gives the height that the skyrocket will rise after it leaves that 6-foot high platform. And we want to know how high will the rocket rise if it has a 5-second fuse. So here, this 5-second fuse, or this 5 seconds, represents our time, which is t. And what we're going to do is we're in our polynomial, we're going to replace, wherever we see t, we're going to replace it with that 5, that value of 5. Okay, so negative 16 times 5 squared plus 200 times 5 plus 6. Okay, so here we're going to have negative 16 times 25 plus 1,000 plus 6. Okay, and so negative 16 times 25 is going to be, let's see, that's going to give us a value of 400. So we have negative 400 plus 1,000 plus 6. So this is 600 plus 6, which gives us a total of 606. And we want to make sure that we bring back our units. So this is going to be a height of 606 feet. So after 5 seconds, the skyrocket will be at a height of 606 feet. So the next thing that we're going to discuss is adding and subtracting polynomials. And before we get into examples of adding and subtracting polynomials, we need to know what like terms are. So like terms are variables that, or this should be terms that have the same variable and the same power. So that's one thing that we want to make sure they have the same variable and the same power. So for example, in this first example, we have r squared plus 2r cubed plus 3r squared. Okay, now this one is pretty easy. We see that our like terms, which I'm going to highlight, are going to be r squared and 3r squared. We're not concerned with the coefficient. We're more concerned that here we have the same variable r and we have the same exponent or the same power of 2. So these two terms would be considered like terms. Okay, now the term in the middle, 2r cubed, would not be a like term because even though it has the same variable, it has a different power order of magnitude or power of 3. So this would be an unlike term. Okay, so in the second example, now here we have two variables. So here we have to check that we know that both variables are the same, p and q, but here we just have to check that the two terms that we're identifying have the same power on both variables. So for example, p squared q to the 5th would be a like term with 4p squared q to the 5th. Okay, and then we also have like terms of p to the 5th q to the 4th. So this is 4p to the 5th q to the 4th and 3p to the 5th q to the 4th. So the two yellow would be like terms and the two blue terms would be like terms. Okay, the next thing that we want to talk about is when a polynomial is in its simplest form. So for example, in this second polynomial, we have like terms, but we have two sets of like terms. In order for a polynomial to be in its simplest form, it has to contain no like terms. So for example, in this example, 4x squared minus 2y plus 6x squared minus 9. Here we have a set of like terms, the 4x squared and the 6x squared. So we're going to collect those like terms by adding their coefficients. When we do that, we get 10x squared minus 2y minus 9. This polynomial right here would be considered in its simplest form because we no longer have any like terms. I've collected all of my like terms from this example and I've simplified this expression. Okay. Also, when we talk about polynomials, we talk about descending and ascending order. A polynomial is in descending order when we have the variable with the highest exponent to the left, and each variable after that has a smaller exponent. So for example, x to the 4th, x squared, x to the 1st, and then our constant of 11. Now, what I want to mention is, which you will see a lot, if you see a variable without an exponent, it's understood to be 1. The same way as if you see just the variable x, the coefficient is understood to be 1. You don't have to write those the 1 either as the exponent or the coefficient. It's understood to be there. Okay, and a polynomial is said to be in ascending order when the constant is on the left and each variable and exponent, each exponent of the variables increase from left to right. Okay, now when we're adding polynomials, there are two properties that we want to keep in mind. We want to keep in mind our commutative property of addition and our associative property of addition. And commutative property, remember, says that no matter which way I group my terms, when I add them, I still get the same result. So for example, if I had 2x plus 7, this would be the same polynomial as if I wrote it 7 plus 2x. Okay, if I had, let's say for associative property, if I had 5 plus the quantity of 2x plus 7, and we want to see if this is equal to the quantity of 5 plus 2x plus 7. Well, here our like terms are constants of 7 and 5. So if I simplify my polynomial, I'm going to get 2x plus 12 on the left-hand side. Same thing here. The like terms are 7 and 5. So if I simplify, I'm going to get 12 plus 2x. And we know by commutative property of addition that these two expressions are indeed the same. Okay? Now, let's actually look at adding and subtracting polynomials. So with adding polynomials, it's very simple. All you do is you group your like terms together, and then you simplify by adding or subtracting their coefficients. So in this example, 5x squared and x squared are like terms. I'm going to group those two together. Now, negative 2x, remember, this is the same thing as plus minus 2x, right? So this would be negative 2x plus x. I'm going to group those two because those are like terms. And then our constants are like terms, so it's 3 plus 2. Here, remember, this is known to be a 1. So we're going to get 6x squared plus negative 2 plus 1 is negative 1. So this is minus x or plus negative x. And then add our constants, we get 5. Now you can leave it as this, but remember plus and minus make minus. So we can write that as 6x squared minus x plus 5. And this would be our simplified expression. And we know that it's simplified because we no longer have any like terms. Now, to subtract polynomials, what we do is we use what we call finding the opposite. So the first thing I'm going to do is I'm going to find the opposite of this second quantity, 2n squared minus 6n plus 8. So we have minus 2n squared minus 6n plus 8. Now notice this minus sign out here. What this minus sign does is that it's regarded as a negative 1. And then what we're going to do is we're going to take and we're going to distribute this negative 1 to each term. That's in my parentheses. So here, negative 1 times 2n squared is negative 2n squared. Negative 1 times negative 6n is positive 6n. And negative 1 times positive 8 is negative 8. So this is my polynomial that I'm now going to add to 5n squared plus 4n plus 3. Okay, so now I'm going to have 5n squared plus 4n plus 3, and I'm going to do this one vertically. So I'm going to line them up. And I'm going to add them together. So remember, the key thing that I want to point out here is once you distribute that negative 1, your subtraction sign now becomes an addition. Okay, and then we're just going to simply add like we did in the previous example. 5 minus 2 is 3. 4 plus 6 is 10n. And 3 minus 8, or 3 plus a negative 8, is negative 5. And so our simplified polynomial becomes 3n squared plus 10n minus 5. Okay, and that is the end of today's lesson.